Let's begin and talk about this question of the day. This was about bitwise operators, and we have two variables a and b. So a is 27, b is 2. That is what we are seeing over here. So what we will first do is we will convert them into binary form, because the way bitwise operators work, they treat the numbers in binary form and then they work. Now, whenever we convert any number into binary form, what we can do is we can write like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, and let's go up to 2 power 5 only. That means this number is 1, 2, 4, 6, 4, 8, 16, and 32. So these are the positional values. Now, if we are looking at 27, so 27 in positional value, we know it is sum of 16, 8, and 16, 8 is 24. 24 plus 2 is 26 plus 1, 27. So what we can easily do is we can write 27 as our A is equal to 1, 1, 0, 1, 1. So sum of these numbers. Same way, let's convert B. B is 2. So 2 is only this number. So 1, 0, rest all zeros. So these are A and B in bitwise forms. So this is, I'll say, the binary form of A and binary form of B. Now let's look at the first expression, which is A ampersand B. So ampersand is bitwise AND operator. And whenever we do ampersand A and B, all bits which are 1, 0, which are 1, 1, only their answer becomes 1, rest all becomes 0. So this will become 1, 1, 0 will become 0, 0, 0 is 0, 1, 0 is 0, 1, 0 is 0. So this is the answer we have. So the answer for first term, this printing should be 2, because this is the binary form. Keep in mind, answer will not be 0, 0, 0, 1, 0. When we print it, the answer will actually get converted into integral answer, and that integral answer will be printed. So output should be 2 rather than the binary form. That's the first. Second, we are doing bitwise OR. So if we say A or B, then the answer should be OR of these two. 1, 0 OR is 1. 1, 1 OR is 1. 0, 0 OR is 0. 1, 0 is 1. 1, 0 is 1. So this number that we are getting, this is nothing but 27 itself. Right, so we get 2 and 27 for first two. Let's see the third one. Bitwise Xor. The way Xor works, it says if both bits are same, it will be 0. If both bits are different, it will be 1. So that is what Xor says. It is exclusive, or one of them should be true. So in this, answer is 1, because this is 1, 0. Here answer is 0, because both are 1, 1. Here answer will be 0, because both are same. Here both are different, answer is 1. Both are different, answer is 1. So this is the answer. Now if you add the value 16 plus 8 plus 1. 16 plus 8 is 24, 1, 25. So this one will be 25. So we got first three answers. Now comes the interesting part. So let me erase whatever we have done so far. So interesting part comes when we come to this complement. Now we need to know certain things for complement, which we will talk about in detail later. But keep in mind, if I have a number A, then its negative minus of A is nothing but it is 2's complement. That means 1's complement of A plus 1. So it is 1's complement plus 1. If you add, that is called 2's complement. And the way computers represent 2's complement of a number is actually negative of that number. Now if we go with this equation, then eventually we can say tilde A is nothing but minus A minus 1. We are just taking 1 on the other side of the equation. So tilde A is minus A minus 1. Right? Now here we are doing tilde A. So tilde A should be, according to this thing, it should be minus 27 minus 1, which is nothing but minus 28. So that should be the answer for A's complement. Same way, if you talk about B's complement, it should be minus 2 minus 1, and that will be minus 3. So the answer for this will be minus 3. So we got these values so far. So let me erase this. Next, if we talk about, it is left shift. So when we left shift the bits, so let's see what happens. So if we are left shifting A, B times, B is 2, we are taking bit pattern of A and shifting it left 2 times. So B, I'll write 2 times. So what will happen when we are left shifting? The first 2 bits will be moving to further left, and there'll be 2 more zeros that get filled. So there are 2 zeros that are filling. Then this is 1 1 0 1 1. So it moves to the left of it. Now integers, we know by default if integers are 32-bit, most languages these days on modern computers have integer as 32-bit. So in 32 bits now, if you see this 4 and this is 4, these are 8 bits only. That means there is more room to move them left. So now what is this number after moving a 2 times to the left? So let's see, this is 2 power 0, 2 power 1, 2 power 2, which is 4, 2 power 3, which is 8, 2 power 4, nothing, 2 power 5, 32, 2 power 6, 64. So this is what we are getting, 64 plus 32 plus 8. So 32 and 8 is, we know, 40. 40 and 4, 44. 44 and 64 will be 108. So this should be the answer. And if we actually see, this answer is nothing but 27 into 4, because one left shift multiplies the number by 2. 27 2s are 54 and 54 2s are 108. So this will have answer as 108. Same way, if we do right shifting, what happens? This number is being right shifted 2 times. So its 2 right bits will be dropped and 2 more zeros will be filled in the beginning. So what we mean by that is, let's see that maths also. Yeah. So when we do a right shift 2 times, 2 zeros come forward, these 2 bits drop, and we are left with 110. So right shift is one right shift will get rid of this bit, another right shift will get rid of this bit. So if this is the number, this is 2 power 0, this is 2 power 1, which is 2, 2 power 2, which is 4. So 4 plus 2 should be 6. So this answer will be 6. And this is nothing but 27 divided by 4. This is integral division. So whatever number of times we are moving, it's 2 power that. So it is 27 by 4. And we know 4 6 are 26. And since it is an integral division, the answer will be 6. So this is the logic behind this exercise, and these are the answers.